Okay, so good morning to everybody who are here. Today we continue with the pandas lecture. Okay, so last lecture we talked about Python and the tools that we have as data scientists. Was there a question now? Sorry.
Николай Алексеевич.
Hello. Okay, I will continue. If someone is yes, is there a
Александр
question?
Юрьевич говорит, что мы не забираем, ну, в Москве как бы накладные не забираться, мы же будем забирать?
I'm sorry, I don't speak Russian. If you want to ask me a question.
Александр Юрьевич, мы все-таки, оказывается, будем забирать накладные с пунктов.
Okay. I suppose this was not a question for me. This was some idle conversation. Anyway, so we talked about we started to talk about the different IDEs that we can use for Python, and we talked about last time we talked about the libraries that we are using for data science, which are numpy, SciPy, pandas, matplotlib, and scikit-learn, also Seaborn, which is a nice high-level interface for drawing attractive statistical graphics. We talked about but I have someone is asking me a question, maybe. Yeah, no one's not from this course. Anyway, so we import, as I said, when we start, before we start coding, we import the important libraries, which are numpy, SciPy, pandas, matplotlib, and Seaborn. And it's very important that we put the standard shorthand, NP for numpy, SP for SciPy, PD for pandas, SNS for Seaborn, because sometimes other people are using our code and we don't want it to interfere with each other. About matplotlib, this is slightly different. The standard notation is not to import the whole library of matplotlib, but matplotlib.pyplot, and we import it as PLT usually. Now let's talk about pandas. So pandas is a very powerful package of Python to manipulate tables. The difference between tables and arrays, NumPy works with arrays of numbers. Tables also have a different meaning for each column. So it's not a matrix, it's a table, and it has columns with different names, and it might have different data types. So it's built on NumPy, but it gives us more flexibility about the data that we have, how to describe the data that we have. So as I said, it's built on NumPy. It includes NumPy, so it's very fast. It works with NumPy, so it's very fast. We don't have to loop through indexes, and we don't have to loop through series. And we can do it very fast. We can do one table at a time. We don't have to work on a single cell. So that's very nice. It saves us a lot of work and a lot of time. And it also allows us to do it, because it incorporates matplotlib in it. It also allows us to do some visualization, very nice visualization without a lot of work. The main data structures of pandas are series and data frames. So let's talk what are series. Series is an indexed one-dimensional array. So basically a vector. So here what we're seeing is that we have data which is 0.25, 0.5, 0.75, and 1. So this is the data. It's one series, and it's indexed. Okay, you can see that it is indexed. 1, 2, 3, 0, 1, 2, 3. That's the indexes of the series. Okay, very simple. Now these are implicit indexes. We can, or indice. We can also use explicit indice.
Is there something on the screen? We can't see it.
Ah, I'm sorry. I didn't share my screen. I'm very, very sorry. My mistake. My mistake. I'm sorry. I forget to share my screen. And you know what? If we talk, I think that how many people are there now in the? How many people are there in the meeting? 13. So I'll make a quick pause, and I want to talk to you about Moodle, about the system, the Moodle system. I've logged into our Moodle system, and I've seen that unfortunately very few people are. Let me. This is the Moodle system. You can see it. Okay, you can see my screen now. So this is our course. Okay, Introduction to Data Science Methods and Tools. So if I look at the names of the students, some students have already accessed this system, the Moodle system. Okay, this is the link. Unfortunately, many students never access this course. Okay, I do not know why. All of you should have access. All of you are all the 30 people are registered with their email addresses. So you should have gotten a message from the Moodle system saying you have access to this. Also, myself and Elisheva are registered. So all the people, all the students in this group should have gotten an email saying you've been registered to this course. Please go to this link. So some of you have accessed this link, but many of you, I would say most of you, did not never access the Moodle system. So it is very important you have the syllabus, okay, on this system. Oh, sorry. So you have the syllabus. This is very important, okay, and you have and you see message. Oh, and you see messages from me. And you have the videos, both the videos and the lecture slides from the my videos and lecture slides. So and also the exercises. Okay, so most of you did not yet. If I look at participants, most of you never accessed this course. So you will not be able to see the course materials. And this is very important that you see it so that you can get good grades and pass them. Also on Vocarium, you are also supposed to get a link from Vocarium, which are the exercises that you need to submit. Also, very few people, only 2, I think, submitted their exercises. So again, 66% of your grades are dependent on these exercises. So it is very important that you go into Vocarium and work on these exercises and submit them. Otherwise, you will not be able to pass this course. Okay, so that was 2 words about the course. I will now go back to the lecture. Okay, I'm using the fact that half of you are already here, but we need to. I needed to address that. Elisheva will also say a few words about that. She will show you those people who didn't get a link to Moodle or did not get a link to Vocarium. Please say so in the auxiliary class to Elisheva, and she will help you with that. Okay, so back to our lecture. As I was saying, the first thing that we need to do is import the libraries. Okay, so we have standard shorthands for numpy, NP, standard shorthand for scipy, SP, for pandas, PD, for matplotlib. This is not what's written here. Matplotlib, we do not usually import the entire matplotlib library, only matplotlib .pyplot, and we usually use PLT as the shorthand. And Seaborn, we use SNS. And as I said, it's important that you use these shorthands so that you do not get interference from other people who use other shortcuts. These are the standard shortcuts. So, as I was saying about pandas, uses the two main data structures, a series and a data frame. As I said, a series, and now you can see my screen, right? So a series is basically a vector of values. These are the values. Once we put an array, a 1D array, or basically a list of values, 0.25, 0.5, 0.75, and 1. And what we get is a vector of values, but they are also indexed. So a series is an indexed list, okay? And again, those the values can be numbers or real numbers, integer numbers, or strings, doesn't matter. And the index can be either implied, so we don't say what the index is, so it gets default indexes 0, 1, 2, and 3, but we can also explicitly define the index, like in here. Okay, I add index and the list of index names, and I get index A, B, C, and D instead. Okay. Now, if I want to access the data, this is the data. So I want to access a single item in the data. I just use square brackets. Okay. Data with the index, and again, if the index is a number, I can put the number. If the index is a string, I can put the string in quotes. Okay, and I get 0.5, which is this. Very simple. So this is a series, and a data frame is very simply sorry, what was there a question? No question? Okay. So a series can, because a series has index and values, it can work as a dictionary. Okay, so or I can define it using a dictionary instead of two lists. So I can use a dictionary saying California and the population, Texas and the population, New York, Florida, Illinois, so on and so forth. And then what I do is I define the series as in terms of the dictionary instead of two lists, which is the same, but now the keys of the dictionary are the indices, or the index, and the values of the dictionary are the values of the series. Okay, and of course, the same way as before, I can use the index to get to a certain value. So population California, I get the number from here. Okay, the same way that I would do with a dictionary, but in a series. And of course, one thing that I can do is I can ask for a not just one index, but several indexes. So they work as an array. So if I ask for the cells for the populations of California up to Illinois, okay, the column tells us that this is from here to here, from California to Illinois. So it will tell me from California to Illinois. So I will get California, Florida, and Illinois with their perspective or their respective populations. Okay. Any questions about the series? Is everything understood about series? What are series? How we can define them? How can we use them? No questions? No questions. So we define the series. What is a data frame? So a data frame is just many series combined together. Okay, so we get, we define the series, for instance, in In this very simple example, we have two series. One is call1 with data 1 and 2, and the other is call2 with data 3 and 4. And now if we say I want a data frame from this data, what I get is a table say with two series, okay, and two indexes or two indices, okay? So the series come in columns and the indices come in rows, okay? Very simple. Okay, everybody understands what a data frame is? Are there any questions about data frames? Open your microphone if you have a question. All of you are muted. You should have questions now because this is, unless this is very, very simple for you. I expect questions right now. No questions whatsoever? If I don't get questions, it's either one of two. Either everything is understood or nothing is understood. You're so either I did a very good job and everybody understood exactly what they need to understand, or I did a very lousy job and you're so overwhelmed with what's happening here that you don't even know how to ask any question. So which case are we in?
No, it's actually pretty clear from the
Good.
image. Yeah, no
Good.
problem.
I'm happy to. Anybody thinks otherwise, that it's not very clear? Good. Okay. So the same way that we used series to define our data frame, we can use a numpy array. So we didn't talk about numpy, but numpy, as I said, involves matrices. So we can construct a matrix using numpy. Okay, here we didn't discuss this, but numpy has, as I said, many methods to create and to manipulate matrices. So here we have a method that allows us to fill a matrix with a size of 5 by 5 with random integer numbers from 0 to 10. Okay, we will not. NumPy is a library that is very important for data scientists, but we will not study it very thoroughly in this course. We will use some of its methods, some of its more, let's say, more basic methods. So one method is to create a matrix which is a random matrix with numbers between 0 and 10, or in this case between 0 and 10. And what I do, I take this matrix and I convert it into a table. Okay, this converts it into a table. How does it convert it into a table? Two things. So the first thing is I say what the columns are, A, B, C, D, and E. So these are the columns. And the second thing, it adds index, right? So I have index, a column of index. I didn't explicitly say what I want is the index to be. So I get the default index, which is 0, 1, 2, 3, and 4. I think it's very simple. Again, if you have any question, don't be afraid to unmute and ask this question. So we saw two ways to construct a data frame. One was from lists, and the other from NumPy array. Now we will see how we create a data frame from two series. Okay, so the first series is the same as earlier. We just take a series of states and their population. Okay, or rather, we define a dictionary. And convert it, we define a dictionary, and then we convert it into a series. So we have one series, the names of the state and the population. Second, we define a second series in the same way, also a dictionary with the state of names. But this time, it's not the population, it's the area of this state, okay? So what we get, same way, we define a dictionary, and we convert it into a pandas series. And the next thing that we need to do, can someone tell me what's the obvious thing to do now? Maybe Agzam of Abdulaziz, can you answer me, please? No? Can you please open your microphone and the camera? I would be very thankful if you do. Okay, Elisheva, please. Okay, yes.
Can you repeat the question? I think I can.
Please help me here. I see that I don't get the answers. Mikhail, I see that you're with me. Can you please answer what's the next thing to do?
Can you just repeat the question? I think I can answer it.
Yes. So I've defined two series: population and area. What do I do next? Can you please? So what is the next thing to do?
You take new variable area and by using pandas against series dictionary.
Exactly.
You just make two columns.
Exactly. So what I do is I define a new data frame, okay, with the population, with one column saying population, and that will take the series population, and one column called area, and that will take the dictionary called area. Okay, and I get basically data frame called states, and it has two columns, area and population. And as you can see, obviously pandas knows how to connect both with the index. Okay, so I have the same index here and here. Okay, I have the same index for the population, California to Texas, and in area from California to Texas. So pandas does the obvious thing and connects them, and I have the same index for California area and population, Florida area and population, and so on and so forth. Okay, so this is very simple, this is very helpful, this is very fast. Okay, let's clear. Any questions so far about data frames? We talked about series, now we expanded this to data frames. Any question? Okay, so a data frame is basically an array of a two-dimensional array, but it also has names for what pandas gives us over numpy is that we have names for the series, which give us an understanding what this number is actually means, and we have names for the index as well. Okay, so this is the difference between a table and an array, and a two-dimensional array. A table also has titles for both our columns and for our indexes. So this allows us to understand better what this table means, what these numbers mean. So this is another example. This time we concern about dates. So what we want to do is, first of all, we want to create a range of 6 dates. So pandas also gives us the ability to make a date range. Pandas has a very good or very extensive class of methods to deal with dates and time and so on. So we make a range of dates from January 1st, 2013, and with 6 periods. Okay, so this will give us basically 6 days. So January 1st, 2nd, 3rd, 4th. This is the American system. Okay, 4th, 5th, and 6th of January 2013. And the data type will be a date time 64. Okay, and now what we want to do is, again, we use the random method from numpy, but this time, instead of random integers, I want to have random floating points and floating point numbers. Okay, so instead of rand int, I use rand n, which is normal distribution. Okay, with standard deviation and mean. And sorry, this is not the standard deviation and mean. This is the size. Okay, this is the size of the matrix. A matrix of 6 by 4, so 6 by 4. Okay, of random numbers, random floating point numbers, with the mean being 0 and standard deviation being 1, I think. And then I give it indices, which are the dates that I already defined here. These are the dates. And I give it column names between A, B, C, and D. It's here, A, B, C, and D. Okay, it's over the columns. And D. Okay, so that's another way to define the data frame object. Now, in terms of the data types that we have, so what we call string in native Python type, we would call an object in pandas. This is the most general data type. If some of our values in that series are numbers and some are strings, or some are integers and some are floats, this will have an object type. This series will have an object type, and of course, integer in Python. In pandas, we will call it int64. Sometimes you can use int32 to save some space, and the float in Python will be called float64. One more thing that we saw that we don't have in Python, not built in data type in Python, which is datetime, which we do have it in pandas, but you can also have you can also import the datetime module in Python and get datetime data type as well. So now that we've already defined our data frame, what can we do with it? So the first thing is to see the head of the data frame. So what are the first, if we don't put any number here, we'll get 5 first rows. Okay, so 5. You remember that I defined a table with 6 rows. I only get 5. I can also put a different number here. If I write 3, I will get the 3 first rows, and so on and so forth. This gives us the ability to fill the data, to see what we have in the data in terms of what are the indices. So I see that here I have dates. What are the column names? So I understand what are the column names, and what is the data in terms of, is it floating point, integer, or object. The same way as using head, I can use tail. Tail gives us the last few rows. So if I don't put any numbers, it will be 5. If I put any number, I will get that number of rows. So here I put 3, and I get the last 3 rows of this data frame. Okay, so this is very simple. If I want to see only the index, so this is an attribute of the data frame. So I put the name of the data frame dot index. This is the attribute index of this data frame, and I get the names of the index. All the indices in this data frame, and of course their data type. On the other hand, if I want to see the names of the columns, I put the name of the data frame dot columns, and I get the names of all the columns. Okay, and again their data types. The third attribute is the values. If I saw the index and the columns, now I want to see the values. So I use df values, and I get all the values as a matrix. Now it's an array. You see, it's an array which is 2-dimensional. Okay, two sets of square brackets, and this is the data that I have, the values of the cells of the matrix. Now, if I want to see the statistics of the data, oh, by the way, any questions so far? Anyone, any question, or is this again simple for you? Good, I'm happy. We lost several people. What happened? I don't know. Okay. We had 16 people, now only 12. What happened? I don't know. In any case, if I want to see some statistics of my data, I use the method describe with parentheses, because this is a method, not an attribute. And I get, for each column separately, I get the count, so the number of values that I have. All of them will be 6, obviously. I get the mean or the average. I get the standard deviation. I get the minimum number, the maximum number, and the 25th percentile or the first quartile, the median and the third quartile. Okay? So this is what the describe does. It describes the data to me. Other important methods that we will want to use, so sorting. I want to sort by, the data, okay? So I want to sort, I can sort over axis 0 or axis 1. Now, in axis 0, this is already sorted, right? I put the dates in the order that I want them. But let's say I want to reverse the order, A, B, C of the columns. A, B, C, D, or D, C, B, A instead of A, B, C, D. So what I will do a sort index, sort by the index, not by the values. This is sort by, these are the values. I don't want to sort by the values. I want to sort by the index. Axis equals 1. Axis equals 1 means I sort over the columns. I can also write axis equals 0, so it will sort over the index. But here, I want to sort over the columns. And I don't want them in ascending order, I want them in descending order. So I put ascending equals false. So this will be descending. And as you can see, it simply reverses the order of the columns. Instead of A, B, C, D, I get D, C, B, A. Okay? Any questions until now? No question. Good. So now I want to sort not by the index, but by the values in the data. So instead of sort index, I use, instead of sort index, okay, I use sort values. Okay, and all I have to do is tell them by which column, and I say by B. So it will now you can see that this is sorted from the smallest value, which is minus 2.1, all the way to the largest value, which is 0.56. And of course, this also sorts. This is sorted by B, but all of the table is sorted now. Okay, so this is the order of each and every row is changed now. Okay, you can see that this is now 3, 4, 1, 2, 6, 5. Okay, so this is sorting. We saw sorting by index and now sorting by value. If I want to access a certain row, what I need to do is I use the method loc, LOC, location. Okay, remember it because it's location. So if I want to see all the dates in place 0, okay, so this is row number 0 basically. What I get, I get one. Now this is not a series. This is one row. So I get the values from the first row, or the first original row, which is 0.462, 0.282, 1.5, minus 1.509, minus 1.135. These are the values that I will get here. Okay? So I get them as a list, or basically as a series. If I want to use a multi-axis, okay, by label. So instead of just saying I want the one place, I want two series, but all of the data on those two series. So I use the colon in the place of the index, and then comma, and then the names of the columns that I want to use, that I want to see. So I get the same method location, but I want all of this denotes that I want all of the data, all of the rows, but I only want, I use again square brackets because this is a list of column names. I want just A and B. Okay? Any questions so far about using the loc method, the location method?
So like the axis is only used for indexation?
Yes, so this is axis number 0 and this is axis number 1. Okay? So if I use a colon on one of the axes, that means I want all of the data, right? And then comma separates between the axes, and then on axis 1, meaning the columns, I want only two of the columns, just A and B, not C and D. Okay? What would happen? What? Sorry?
Yeah, now it's understood. Thank you.
Okay, so what will happen if I say df dot loc colon comma colon? What will I get?
You will get all the dates and all the data, like all the columns.
Exactly. Good. I just wanted to make sure that everything is understood. Any other questions, or is everything understood? Good. Okay. So and again, if I want to just take some rows, I would use I want only these rows between January 2nd and January 4th. Okay, so again I use the colon. The colon says that I want from this row to this row, with again the same columns A and B. Okay, so I get only 3 rows instead of all 6. Okay. And by the way, this is a bit different than Python, because here this also includes the last one. Okay, so if you can see that I define between January 2nd and January 4th, I also got January 4th. The last one is included as well. Okay. Now, if I want to use by the location, rather the specific location rather than the index, I use iLocation instead of location. Okay, so if I want to take the third, or rather the fourth, because the first one is 0, obviously. So if I want to take the third row, or second the fourth row, I would use iLoc3, and I get the fourth row. Okay, so the fourth row is of course January 4th. I don't use the name of the index. I use the position, the location. Okay, and if I want to take not a row but a single cell or a range of cells, I can use the same iLoc, but now what I'm using is let's say here I have a range between 3 and 5, and this is this is axis 0, right? So these are the indexes. So this is the third index and the fourth index, and now 5 is not included, and between 0 and 2 means again 2 is not included, 0 is A, and 1 is B. Okay, so okay, and again, and you need to make a distinction here. We do not include the last sample in iLoc, lock includes the last sample. Okay, the last one is included. So this is a bit different. Now, I can also do what's called Boolean indexing. I want to see where do I have values that are greater than 0. Okay, let's return here. So you can see that I have values that are larger than zeros and values that are smaller than zeros, right? So I want to see where do I have values that are larger than 0. Where was that? Here. So what I do is I put a square brackets and I put a Boolean condition. So a data frame where data frame is larger than 0. So I get the same numbers. I get only the positive numbers, so the numbers that answer my condition, and the numbers that do not answer my condition get a none. None is not a number. So this is not a number, none. Okay, we will see how we can deal with nuns later. But this is everywhere where it's not defined or where the condition is not met, I get not a number. So I get only the positive numbers.
So it's like null.
None is like null, yes. There are different Python libraries use different notations for the null or none. Or Python itself use none. NumPy use NA, not available, and in pandas it's called none, not a number. Okay, there should be a number, but there is no number. So let's see. So now what I want to do, I copy. This is another very important method. Copy. I want a copy of the first data frame. If I don't use a copy, if I don't have this and I define df2 equals df data frame, they will both point to the same table. I don't want that. I want to make another table and manipulate that. So I have to use copy. Okay, I cannot say df2 equals df. Because I want to manipulate it. So what I'm doing is I'm writing df2 equals df dot copy. This is very important. Now that I have a copy of the table, I can now manipulate it. What I do is I add one more series. I had 4 series A, B, C, and D. Now I add one more series E. And this will be a series of strings, and this will be just the numbers 1, 1, 2, 3, 4, and 3. So if I look at the table now, I see that I have one more column with the strings 1, 1, 2, 3, 4, and 3. Now, I want to another Boolean indexing is by defining which values are in a list of values. So that would be is in. So I have a list of values 2 and 4, and I want to see where do I have the strings 2 or 4, either 2 or 4 in my series E. So I will use the same notation, df2 square brackets df2, where E or the series df2 E, the series E in data frame 2, where the value is in the list either 2 or 4. So this will not do, this will not do, this will not do. So I get only 2 places where the value in E is either 2 or 4, and these are the places. So I get only these rows. Okay, these rows. And as you can see, what I receive is again these rows. January 3rd and January 5th with all the values. Only where the cells in E are either 2 or 4. Is this understood? Is everything understood so far? Okay, so we've finished our, it's now 9:46, so I will now finish. We will continue next week. I will pass on the class to Elisheva, to my assistant. She will do an exercise with you. Elisheva, please.
Hi.
Hi, how are
Good
you?
morning.
Everything okay? Now
Yes,
I have
everything
a
okay.
problem that almost no one opened their cameras during the class. So I want you to
Why?
take. That's a good question. So I want you during your exercise to register the participants.
Okay.
And only register those who are with an open camera, okay? So that you
Okay.
can see their faces and hear their voice. So
Okay.
I sent you the exercise. We exercise in pandas, right?
Right.
Yes. So starting at 10, please do an exercise with the class, and I pass on the responsibilities to you. Okay. Have a nice
Okay.
day.
Have a
Thank
nice
you
day.
so
Bye-bye.
much. Thank
Thank you
you
to you.
so much. Bye bye.
Okay. So please, we will have a recess until 10 a.m. and we will start at 10 a.m. Okay. You listen to me?
Yeah, I can hear you, but the sound is too low.
Okay. I will restart. Wait a minute.